The following documentary presents new developments in neuroscience and a solution to the many current unsolved problems in physics. While it keeps clear of metaphysical correlations and is solely focused on scientifically verifiable data, it also has philosophical repercussions pertaining to life, death, and the origin of the universe. Due to its many layers and density in presentation, it may require multiple viewings to fully comprehend its implications, even though considerable effort has been made to simplify the complex scientific concepts that are discussed. Furthermore, I would like to thank the author for allowing me to follow and report on his work, as he wanted to remain dedicated to his research and avoid becoming involved in its media coverage. The human brain is a network of approximately 100 billion neurons. Different experiences create different neural connections which bring about different emotions. And depending on which neurons get stimulated, certain connections become stronger and more efficient, while others may become weaker. This is what's called neuroplasticity. Someone who trains to be a musician will create stronger neural connections that link the two hemispheres of the brain in order to be musically creative. Virtually any sort of talent or skill can be created through training. Rudiger Gamm, who was a self-admitted hopeless student, used to fail at basic math and went on to train his abilities and became a famous human calculator, capable of performing extremely complex mathematics. Rationality and emotional resilience work the same way. These are neural connections that can be strengthened. Whatever you are doing at any time, you are physically modifying your brain to become better at it. Since this is such a foundational mechanism of the brain, being self-aware can greatly enrich our life experience. Specific neurons and neurotransmitters, such as norepinephrine, trigger a defensive state when we feel that our thoughts have to be protected from the influence of others. If we are then confronted with differences in opinion, the chemicals that are released in the brain are the same ones that try to ensure our survival in dangerous situations. In this defensive state, the more primitive part of the brain interferes with rational thinking, and the limbic system can knock out most of our working memory, physically causing narrow-mindedness. We see this in the politics of fear, in the strategy of poker players, or simply when someone is stubborn in a discussion. No matter how valuable an idea is, the brain has trouble processing it when it is in such a state. On a neural level, it reacts as if we're being threatened, even if this threat comes from harmless opinions or facts that we may otherwise find helpful and could rationally agree with. But when we express ourselves and our views are appreciated, these defense chemicals decrease in the brain, and dopamine neurotransmission activates the reward neurons, making us feel empowered and increasing our self-esteem. Our beliefs have a profound impact on our body chemistry. This is why placebos can be so effective. Self-esteem or self-belief is closely linked to the neurotransmitter serotonin. When the lack of it takes on severe proportions, it often leads to depression, self-destructive behavior, or even suicide. Social validation increases the levels of dopamine and serotonin in the brain, and allows us to let go of emotional fixations and become self-aware more easily. Social psychology often looks at the basic human need to fit in and calls this the normative social influence. When we grow up, our moral and ethical compass is almost entirely forged by our environment, so our actions are often a result of the validation we get from society. But new developments in neuroscience are giving us a better understanding of culture and identity. Recent neurological research has confirmed the existence of empathetic mirror neurons. When we experience an emotion or perform an action, specific neurons fire, but when we observe someone else performing this action, or when we imagine it, many of the same neurons will fire again, as if we were performing the action ourselves. These empathy neurons connect us to other people, allowing us to feel what others feel. And since these neurons respond to our imagination, we can experience emotional feedback from them as if it came from someone else. This system is what allows us to self-reflect. The mirror neuron does not know the difference between it and others, and is the reason why we are so dependent of social validation and why we want to fit in. We are in a constant duality between how we see ourselves and how others see us. This can result in confusion in terms of identity and self-esteem, and brain scans show that we experience these negative emotions even before we are aware of them. But when we are self-aware, we can alter misplaced emotions because we control the thoughts that cause them. This is a neurochemical consequence of how memories become labeled when retrieved, and how they are restored through protein synthesis. Self-observing profoundly changes the way our brain works. It activates the self-regulating neocortical regions, which give us an incredible amount of control over our feelings. Every time we do this, our rationality and emotional resilience are strengthened. When we are not being self-aware, most of our thoughts and actions are impulsive. And the idea that we are randomly reacting and not making conscious choices is instinctively frustrating. The brain resolves this by creating explanations for our behavior and physically rewriting it into our memories through memory reconsolidation, making us believe that we were in control of our actions. This is also called backward rationalization, and it can leave most of our negative emotions unresolved and ready to be triggered at any time. They become a constant fuel to our confusion, as our brain will keep trying to justify why we behaved irrationally. All this complex and almost schizophrenic subconscious behavior is the result of a vastly parallel distributed system in our brain. There is no specific center of consciousness. The appearance of a unity is in fact each of these separate circuits being enabled and being expressed at one particular moment in time. Our experiences are constantly changing our neural connections, physically altering the parallel system that is our consciousness. Direct modifications to this can have surreal consequences that bring into question what and where consciousness really is. If your left cerebral hemisphere were to be disconnected from the right, as is the case in split brain patients, you would normally still be able to talk and think from the left hemisphere, while your right hemisphere would have very limited cognitive capacities. Your left brain will not miss the right part, even though this profoundly changes your perception. One consequence of this is that you can no longer describe the right half of someone's face, but you will never mention it. You will never see it as a problem or even realize that something has changed. Since this affects more than just your perception of the real world and also applies to your mental images, it is not just a sensory problem, but a fundamental change in your consciousness. Each neuron has a voltage, which can change when ions flow in or out of the cell. Once a neuron's voltage has reached a certain level, it will fire an electrical signal to other cells, which will repeat the process. When many neurons fire at the same time, we can measure these changes in the form of a wave. Brainwaves underpin almost everything going on in our minds, including memory, attention, and even intelligence. As they oscillate at different frequencies, they get classified in bands such as alpha, theta, and gamma. Each are associated with different tasks. Brainwaves allow brain cells to tune into the frequency corresponding to their particular task while ignoring irrelevant signals, similar to how a radio homes in on different waves to pick up radio stations. The transfer of information between neurons becomes optimal when their activity is synchronized. This is the same reason why we experience cognitive dissonance, the frustration caused by simultaneously holding two contradictory ideas. Will is merely the drive to reduce dissonance between each of our active neural circuits. Evolution can be seen as the same process where nature tries to adapt or resonate with its environment. By doing so, it evolved to a point where it became self-aware and began to ponder its own existence. When a person faces the paradox of wanting purpose while thinking that human existence is meaningless, cognitive dissonance occurs. Throughout history, this has led many to reach for spiritual and religious guidance, challenging science as it failed to give answers to existential questions, such as why or what am I? The left cerebral hemisphere is largely responsible for creating a coherent belief system in order to maintain a sense of continuity towards our lives. New experiences get folded into the pre-existing belief system. When they don't fit, they are simply denied. Counterbalancing this is the right cerebral hemisphere, which has the opposite tendency. Whereas the left hemisphere tries to preserve the model, the right hemisphere is constantly challenging the status quo. When the discrepant anomalies become too large, the right hemisphere forces a revision in our worldview. However, when our beliefs are too strong, the right hemisphere may not succeed in overriding our denial. This can create a profound confusion when mirroring others. When the neural connections that physically define our belief system are not strongly developed or active, then our consciousness, the unity of all the separate active circuits at that moment, may consist mainly of activity related to our mirror neurons. Just as when we experience hunger, our consciousness consists mostly of other neural interactions for consuming food. This is not the result of some core self giving commands to different cerebral areas. All the different parts of the brain become active and inactive and interact without a core. Just as the pixels on a screen can express themselves as a recognizable image when in unity, the convergence of neural interaction expresses itself as consciousness. At every moment, we are in fact a different image, a different entity when mirroring, when hungry, when watching this video. Every second, we become different persons as we go through different states. When we use our mirror neurons to look at ourselves, we may construct the idea of identity. But if we do this with our scientific understandings, we see something completely different. The neural synergies that produce our oscillating consciousness go far beyond our own neurons. We are equally the result of cerebral hemispheres interacting electrochemically, as we are of the senses connecting our neurons to other neurons in our environment. Nothing is external. This is not a hypothetical philosophy. It is the basic property of mirror neurons, which allow us to understand ourselves through others. Seeing this neural activity as your own while excluding the environment would be a misconception. Our superorganismal features are also reflected in evolution, where our survival as primates relied on our collective abilities. Over time, the neocortical regions evolved to permit the modulation of primitive instincts and the overriding of hedonistic impulses for the benefit of the group. Our selfish genes have come to promote reciprocal social behaviors in superorganismal structures, effectively discarding the notion of survival of the fittest. The brain's neural activity resonates most coherently when there is no dissonance between these advanced new cerebral regions and the older, more primitive ones. What we traditionally call selfish tendencies is only a narrow interpretation of what self-serving behavior entails, wherein human characteristics are perceived through the flawed paradigm of identity, instead of through a scientific view on what we are, a momentary expression of an ever-changing unity with no center. The psychological consequences of this as an objective belief system allow self-awareness without attachment to the imagined self, causing dramatic increases in mental clarity, social conscience, self-regulation, and what's often described as being in the moment. The common cultural belief has mostly been that we need a narrative, a diachronic view on our life to establish moral values. But with our current understandings of the empathic and social nature of the brain, we now know that a purely scientific view with no attachment to our identity or story yields a far more accurate, meaningful, and ethical paradigm than our anecdotal values. This is logical since our traditional tendency to define ourselves as imaginary individualistic constants neurally wires and designs the brain towards dysfunctional cognitive processes, such as compulsive labeling and the psychological need to impose expectations. Practical labeling underpins all forms of interactions in our daily lives. But by psychologically labeling the self as internal and the environment as external, we constrain our own neurochemical processes and experience a diluted disconnection. Growth and its evolutionary side effects, such as happiness and fulfillment, are stimulated when we are not being labeled in our interactions. We may have many different views and disagree with one another in practical terms, but interactions that nevertheless accept us for who we are without judgment are neuropsychological catalysts that wire the human brain to acknowledge others and accept rationally verified belief systems without dissonance. Stimulating this type of neural activity and interaction alleviates the need for distraction or entertainment and creates cycles of constructive behavior in our environment. Sociologists have established that phenomena such as obesity and smoking, emotions and ideas spread and ripple through society in much the same way that electric signals of neurons are transferred when their activity is synchronized. We are a global network of neurochemical reactions, and the self-amplifying cycle of acceptance and acknowledgement, sustained by the daily choices in our interactions, is the chain reaction that will ultimately define our collective ability to overcome imagined differences and look at life in the grand scheme of things. Throughout Jiren's ongoing research, I've made a simplified but comprehensive overview of his current findings. This is my interpretation of the first few months of his work on unifying quantum physics and relativity. While it may at times be difficult to follow due to the subject matter's complexity, it also has some philosophical implications which are addressed in the epilogue. Over the past century, many groundbreaking discoveries have led to scientific paradigm shifts in our understanding of the world. Einstein's theory of relativity revealed how time and space are the same fabric, while Niels Bohr's research helped us understand the building blocks of matter through quantum physics, a realm that only exists as an abstract physical description. Afterwards, Louis de Broglie discovered that all matter, and not just photons or electrons, has a quantized wave-particle duality. These breakthroughs have led to new schools of thought about the nature of reality and have inspired popular metaphysical and pseudoscientific theories, such as the human mind being able to command the universe through positive thinking. However attractive, these theories have no verifiable evidence and can slow down scientific progress. Einstein's laws of special and general relativity are applied in modern-day technologies, such as GPS satellites, where the accuracy of calculations would drift more than 7 miles a day, if consequences such as time dilation would not be taken into account. Time dilation is best illustrated by how moving clocks run slower. Other implications of relativity are length contraction, meaning that objects in motion decrease in length, and the relativity of simultaneity. It is impossible to say in an absolute sense whether two events occur at the same time when they are separated in space. Nothing can travel faster than the speed of light. This means that if a bar of 10 light seconds long would be pushed forward, it would take 10 seconds before the action can take place on the other side. Without this time interval of 10 seconds, the bar does not exist in its entirety. This is not due to our limitations as observers, but due to an inherent consequence of relativity, where time and space are interconnected and cannot exist without each other. Quantum physics provides a mathematical description of much of the wave-particle duality and interactions of energy and matter. It departs from classical physics primarily at the atomic and subatomic scales. The mathematical formulations are abstract, and the implications are often non-intuitive. A quantum is the minimum unit of any physical entity involved in an interaction. The elementary particles are the basic building blocks of the universe. They are the particles which all other particles are made of. While in classical physics we can always split things into smaller bits, for quanta this is impossible. As a result, the quantum world presents many unique phenomena that cannot be explained through classical laws, such as quantum entanglement, the photoelectric effect, Compton scattering, and many more. There are many exotic interpretations of our quantized world. The most widely accepted among physicists include the Copenhagen interpretation and the many worlds interpretation. Current trends show substantial competition from alternative interpretations such as the holographic universe. While both quantum physics and Einstein's laws of relativity are essential to our scientific understandings of the universe, there are many unsolved scientific problems, and thus far, no unifying theory. Some of the current questions are: why is there more observable matter than antimatter in the universe? What is the nature of the arrow of time? What is the origin of mass? One of the most important keys to finding the answer to these problems are de Broglie's equations, for which he was awarded the Nobel Prize in Physics. This formula shows how all matter has a wave-particle duality, meaning that there are moments in which it behaves as a wave, and others where it behaves as a particle. The formula combines Einstein's famous E is mc² equation with the quantized nature of energy. Experimental evidence includes the interference pattern of C60 fullerene molecules in a double-slit experiment. The fact that our consciousness itself seems to be made up out of quantized particles has been the subject of many mystical theories. And while the relation between quantum mechanics and consciousness is unlikely to be as magical as recent esoteric movies and literature claim, there is nevertheless a profound implication. As de Broglie's equations apply to all matter, we can fundamentally establish that C equals hf, where C stands for consciousness, h for the constant of Planck, and f for frequency. C is responsible for what we experience as the now, a quantized or minimum unit of an interaction. The sum of all moments C up till the current moment is what shapes our concept of life. This is not a philosophical or theoretical statement, but an inherent consequence of all matter and energy being quantized. The formula shows how life and death are abstract constructions of C. Another consequence of de Broglie's equations is that the rate at which matter or energy fluctuates and acts like a wave or a particle is relative to the frequency of the frame of reference. Increases in frequency due to velocity are relative to others and bring about phenomena such as time dilation. The underlying reason is the unaffected experience of time relative to the reference frame, where space and time are properties of quanta, and not the other way around. Antiparticles are created everywhere in the universe where high-energy particle collisions take place. This process is artificially simulated in particle accelerators. When matter is created, antimatter is created simultaneously. Hence why the lack of antimatter in the universe is one of the biggest unsolved questions in physics to date. When we trap antiparticles through electromagnetic fields, we can study their properties. The quantum state of particles and antiparticles can be interchanged by applying the charge conjugation, parity, and time reversal operators. To clarify, if a physicist whose body was made of antimatter would do experiments in a laboratory also made of antimatter, using chemicals and substances of antiparticles, he would find almost exactly the same results as his matter counterpart. But when they would merge, immense energy would be released proportional to their mass. Very recently, Fermilab discovered how quanta such as mesons are switching 3 trillion times per second from matter to antimatter. When we study the universe from a quantized frame of reference C, we have to take into account all experimental evidence that applies to quanta. This includes how matter and antimatter are created simultaneously in particle accelerators, and how mesons switch back and forth between one and the other. This has significant consequences when applied to C. From a quantum perspective, every instance of C has an anti-C. This explains the missing symmetry or antimatter in the universe and is closely related to the arbitrary choice of emitter and absorber in the Wheeler-Feynman time-symmetric theory. The unperturbed time t in the uncertainty principle is the required time or cycle for quanta to exist. Similar as observed in mesons, our personal experience of time or interval of the current moment reaches its threshold when C is cancelled out by its anti-C. C's interpretation of this single self-annihilating moment is framed within an abstract arrow of time. If we then want to define interaction and look at the basic properties of the wave-particle duality of quanta, all interactions would consist of interference and resonance. But since this isn't enough to explain the fundamental forces, we are required to use different models. This includes the standard model, which mediates the dynamics of the known subatomic particles through force carriers, and Einstein's general relativity, which describes macroscopic phenomena such as the orbits of planets, which follow a curvature or ellipse in space and a helix in space-time. But Einstein's model of space-time doesn't hold up on quantum levels, and the standard model needs additional force carriers to explain the origin of mass. Without success, a unification of both models or theory of everything has been subject of much research. Quantum mechanics is merely mathematical descriptions, and their practical implications are often counterintuitive. Classical concepts such as length, time, mass, and energy can also be approached with similar descriptions. By building on de Broglie's equations, we can substitute these concepts with abstract vectors. This is a probability-oriented approach towards the basic and already existing concepts in physics that allows us to unify quantum mechanics with Einstein's relativity. De Broglie's equations show how all reference frames are quantized, including all matter and all energy. Particle accelerators have demonstrated that matter and antimatter are always created simultaneously. The paradox of how reality can emerge from abstract building blocks that annihilate each other can be explained by using these quanta as the frame of reference. In a simplified analogy, we need to look at things through the eyes of a photon. The reference frame is always a quantum and defines how spacetime is quantized. When it increases or decreases, spacetime increases or decreases as well. This is reflected in quantum mechanics as the mathematical description of the probability amplitude of the wave function, or in Einstein's relativity as time dilation and length contraction. For a quantized frame of reference, mass and energy can only be defined as abstract probabilities. Or if we want to be more concrete and establish a mathematical framework, as vectors which can only exist when we assume an arrow of time. They can be derived as resonance and interference with the reference frame, which defines the minimum unit or spacetime constant c, equivalent to the constant of Planck in quantum mechanics. Experiments show how conversion of matter into energy through its antimatter brings about gamma rays with exact opposite momentum. What seems to be a conversion is the ratio between opposite vectors interpreted as distance and time, matter and antimatter, mass and energy, or interference and resonance within the abstract arrow of time of c. The sum of opposite vectors is always zero. This is the reason for the symmetry or conservation laws in physics, or why at the speed of c, time and space are zero due to length contraction and time dilation. A consequence is the Heisenberg uncertainty principle, which states that certain pairs of physical properties, such as position and momentum, cannot be known simultaneously to high precision. In a sense, a single particle is its own field. This does not explain our sense of continuity, where c cancels itself out within its own required interval. But when these vectors are exponentially amplified or accelerated relative to and within the abstract arrow of time, the underlying mathematical algorithms, also describing the fundamental forces, can bring about a consistent reality and have abstract building blocks. This is why the harmonic motion equations are used in many fields of physics involving periodic phenomena, such as quantum mechanics and electrodynamics, or why Einstein's equivalence principle, used to derive the model of spacetime, states that there is no difference between gravity and acceleration. Because gravity is only a force when interpreted relative to an oscillating frame of reference. This can be illustrated with a logarithmic spiral curve being reduced to a helix curve by the reference frame, making objects spin and move in orbits. Visually simplified, two amplified or growing apples will be interpreted to attract each other when observed by an amplified reference frame, as the size seems unaffected. The opposite occurs with interference. In a simplified analogy, the increase or decrease in the size of objects as we get closer or further away is determined by the shift in vectors of the reference frame, similar to how a radio homes in on different waves to pick up radio stations. This also applies to the influence of gravity. In essence, independently of any reference frame, there are no fundamental forces. All interactions within our abstract continuity can be mathematically derived through interference and resonance as long as the ever-changing and fluctuating minimum unit or quantum, being the frame of reference, is taken into account. Experimental evidence includes the unseen effect in the standard model, where we can see the force effect, but not the actual force carriers. The consistent continuity of reality does not require quanta to have any specific sequence in time. A quantum is not subject to any notion of space or time and can occupy all of its possible quantum states simultaneously. This is called quantum superposition and has been demonstrated in experiments such as the double-slit experiment or quantum teleportation, where every electron in the universe, for example, could be the exact same one. The only requirement for an abstract arrow of time and consistent continuity or reality is the algorithm describing the pattern or abstract sequence of vectors. Since this continuity brings about our ability to be self-aware, it inherently makes us subject to its mathematical consequences, the fundamental laws of physics. Interaction is merely an interpretation of what is essentially an abstract pattern. This is why quantum mechanics can only provide mathematical descriptions, since it can only describe patterns within infinite probabilities. When a probability is expressed as C, The information necessary to describe the current moment or probability amplitude of C is also what embodies the arrow of time. The nature of the arrow of time is one of the biggest unsolved problems in physics and has been responsible for many new popular interpretations. The holographic principle, for example, a property of quantum gravity and string theories, theorizes how the entire universe can be seen as an information structure of only 2 dimensions. Traditionally associate the notion of an arrow of time with the sequence of events that we experience through the arrangement of short-term and long-term memories. We can only have memories about the past and not about the future, and we've always assumed that this reflects the flow of time. Scientists only began to question this logic when discoveries in quantum mechanics demonstrated that some phenomena are not bound by our notion of time, and that our concept of it is nothing more than our perception of the change in observable values. This is also reflected in time dilation and length contraction, which are part of the reason why Einstein established that time and space are the same fabric. In an absolute sense, the notion of time does not differ from the notion of distance. Seconds are equal to light seconds but cancel each other out. To clarify, with distance and time being each other's opposites, the passing of time can be interpreted as the distance that the hands of a clock travel as they move in a direction that is opposite to time. As they move forward in distance, they effectively travel backwards in what we would call time. This is also why any single separate minimum unit of experience is always instantly annihilated within a timeless now. This understanding sets the record straight between wave function collapse and quantum decoherence. Concepts such as life and death are mere intellectual constructs, and any speculative spiritual ideas of an afterlife that takes place in a realm where the rigid mathematical underpinnings of this reality come to an end are equally fabricated. An important cosmological consequence is that the Big Bang theory, where the universe is traced back to one point by looking at the past, is a misconception. The traditional assumption of spacetime, where space is 3-dimensional and time plays the role of a 4th dimension, is inaccurate. If we would want to study the origin of the universe, we would actually have to look forward, since C's time vector direction is opposite to the arrow of distance, from which we perceive an expanding universe. Although this temporal mapping of the universe will only yield abstract concepts with no relation to its quantum underpinnings. Experimental evidence includes the accelerating expanding universe, following what is known to be an inverse or time-reversed black hole metric, as well as the many problems related to the Big Bang theory, such as the horizon problem. These derivations could bring up questions about free will, since awareness seems to only take place after the action within our perception of time. Most neurological investigations that have shed light on this question show that action is indeed taken before becoming conscious of it. But a deterministic point of view is based on an erroneous concept of time, as is illustrated by the mathematical probability descriptions in quantum mechanics. These understandings will be relevant for future neurological research, since they show how any neural circuit is a vector with direction, underpinning cognitive dissonance and interference or resonance within C. The ability to understand and consciously alter these directions, acquired through billions of years of evolution, confirms how important our belief systems are in expanding our awareness, and how they affect our working memory, which is responsible for the extent to which we can make connections and for the neural processes that create meaning. It also explains how artificial awareness will require a network of independent processors instead of a linear sequence of complex algorithms. Athene's grand unification is one solution that unifies quantum physics and Einstein's theory of relativity. While it answers many problems in physics, such as the ones listed here, it is my limited interpretation of his first months of scientific research. Whatever the outcome, it is clear that we have entered an era where science is open to everyone. And if we can preserve unfiltered access to a neutral internet, we can test the validity of our ideas. We can enhance our imagination by making new correlations. And we can be part of the evolution of our understandings of the universe and of the mind. In quantum mechanics, we have learned to approach reality differently and see everything as probabilities instead of certainties. In a mathematical sense, anything is possible. As well as in science as in our daily lives, the extent to which we can calculate or figure out probabilities is determined by our intellectual capability to recognize patterns. The less biased we are, the clearer we can identify these patterns and base our actions on reasonable probabilities. Since it's in the very nature of our brain's left hemisphere to deny ideas that do not fit into our current paradigm, the more attached we are to a belief system, the less able we are to make conscious choices for ourselves. But by observing this process, we expand our awareness and enhance our free will. It is said that wisdom comes with age, but with openness and skepticism, the key principles of the scientific method. We don't need decades of trial and error to sort out which of our convictions may be improbable. The question is not whether our beliefs are right or wrong, but whether or not being emotionally attached to them is more or less likely going to benefit us. There is no such thing as a free choice while being emotionally attached to a belief system. The moment we are self-aware enough to realize this, we can truly work together to figure out the real odds of what will benefit us the most.